Okay, so we're starting section 7.3, which deals with similar right triangles. Remember last chapter, we dealt with similar triangles being proportional. In this chapter, we're dealing with specifically right triangles. And so we're bringing back this concept of similarity. And remember, similar means proportional. So we're dealing with proportional right triangles. Now, what I want you to look at, and actually first we're going to take a little note, I want you to understand something. This is a very difficult section for some students because it requires you to manipulate and alter objects in your mind in order to make connections between them. To help, you might find it easier to redraw the following triangles in similar positions. What we're going to do is we're going to be given a triangle, and we're going to look at this diagram right here. We're given a triangle, and then we're actually told that if you draw a straight line going from the right angle to the base, which is called an altitude, if you draw an altitude in that original right triangle, you then create two smaller triangles. You create a triangle that looks like this, and then a triangle that looks like this. And those two originally created the whole. But not only do you create two smaller triangles, what in essence you get is three similar triangles. The bigger one, the largest one being the one we started with. When we drew the altitude, we then got a second and a third right triangle, all three of which are similar, meaning all three are proportional. And this is where it can get tough because, and you'll see here in a second when we go into an example, you're given different pieces and you have to try and relate what piece do I have of which triangle and how can I relate that to the other triangles. The whole goal of this is to create a proportion where you have quantities between two triangles. So maybe in one problem they give you the base and the hypotenuse, and then they give you the base and they don't give you the hypotenuse in another triangle. You need to understand that because these two triangles are similar, we can build proportions with corresponding sides. If they've given me the base in both, and again, you'll notice this little triangle right here is not in the same position as this one. So you may have gotten confused when I said that this is the base. It's like, no, that's the height. It's standing straight up, that's the height. We have to actually draw all three triangles in similar positions so that we can see what corresponding parts they have. I hope that's not too confusing. And let me erase this and just kind of backtrack a little bit just to make sure that I've really done a good job of explaining it. If this is our original triangle, you'll notice that if this is the right angle, the hypotenuse is actually down. Okay? AB of this largest triangle would be the hypotenuse. But then, when we break it up into the two smaller triangles, still having the largest one here, then when we break it down into the two smaller ones, we'll notice that they are not in the same position. In this one, the hypotenuse is going up and left, and this one, the hypotenuse is going up and right. So one of the best ways that I'll tell you, and I'll tell you this for the next day or two, as long as it takes us to get through this section, I'll tell you constantly to be redrawing these triangles so that they are in similar positions. And when I say similar positions, I mean this. Take your original triangle, and if it's drawn like this, with the hypotenuse going down, then redraw the other two with the hypotenuse going down so that they are all three in the same position. And now you can see that the hypotenuse of all these three triangles is going down. You can see that the smallest side, okay, are all in the same position. And then you can see that the third side, just that middle side, is all in the same position. Because all these three triangles are now in the same position, so to speak, now we can actually say, well, I see I have this side of this triangle and this side of this triangle, and I can use those to establish a proportion. This is very, very tough for some kids because they can't redraw them, or they choose not to redraw them, and then they end up looking at this image right here, and they're told this is 5, this is 6, this is X, and this is 4, and are told to solve the triangle, and they have no idea how. So redrawing it will show you that you can solve for that X. Now go to the next page, and we've got a couple examples, because the best way to do this is just to practice. I'm going to start off with this one. We're going to label this letter A, just so that we have a starting point. And in letter A, I see that I have a right triangle. I'm going to start off by highlighting that right triangle. It's right triangle EGF. Okay? And in EGF, they've given me 3, 4, and 5. I have all 3 parts of my right triangle. But inside that right triangle, I'm now given 2 more. I'm given EGH, and I'm given FHG. Now, it's very important that the first thing you try and do is draw them in the same position. Okay? Now, what I want you to see is that EGF is currently drawn with the 90-degree angle down, the hypotenuse up and right. So that's what I'm going to try and do. I'm going to try and draw EGH. I'll use blue so that you can see it. Here's the 90-degree angle. I want that down. The 90-degree angle down. And then I want the hypotenuse going up and right. 3 is the hypotenuse, so that's here. And now I'm going to go through and actually label the points. This should be E. This should be H. This should be G. Actually, let me use blue on all those so that we don't get too confused with it. I love the back button. Probably overuse it, but I like it. There's 3, E, H, and G. And now I'm going to redraw triangle FHG. I can see that my hypotenuse is the letter 4, or the number 4, and that H is still my right angle. So when I draw my right triangle, and redrawing them might be a challenge for some of you. Just that idea of you've got to figure out, okay, I've got to rotate it, I've got to manipulate it. H is still right here, okay? But then F is actually the, I guess you could call it the smallest angle here, and so it goes way down here, and then G is up here. So you see now we have 3 triangles. Let me re-highlight this top one so you can see we have EGF. Looks like that. Then we have EHG and GHF. And then we have X, which is right here. It's HG. But this is what can be confusing. If you look at HG, you'll notice that it occurs not only in my red triangle right here, but it is also in my blue triangle right here. Okay? That can be very, very confusing. Not that it's 2 different values, but because it appears in 2 of my different triangles. Now, when you solve your proportion, you're going to get the same value. X can't change values. It can't be 3.2 and 4.5. It's going to equal 1 answer. But the question is, which triangle do you want to use to set up a proportion? Now, if you think of, let's say you're going to solve this one right here. Okay? Let's say you randomly pick and say, I'm going to use this triangle to solve it. What you have to do is you have to say, okay, I'm given the hypotenuse and the base. Am I given the hypotenuse and the base in any of my other triangles? And the answer is yes. You are given the hypotenuse and the base in your largest triangle. Well, you can say that the hypotenuse of my small triangle is proportional to my hypotenuse of my larger triangle. 3 to 5, hypotenuse to hypotenuse. And that should equal, because they're similar, that should equal the proportion of X to 4, because that's base to base. Now if I cross multiply, I get 5 times X equals 3 times 4, which is 12. And if I divide both sides by 5, I'm given X equals 2.4. Okay? Now, just to prove to you that you can use either one of these triangles, we're going to now solve the exact same thing using this triangle. You only have to solve it once, remember, but just to show you there's multiple ways of doing it, I'm going to solve this one too. Now, you're given, in this triangle, you are given the height and the hypotenuse. Now, you need to figure out another triangle where you're given the exact same information so that you can use it to compare. And you'll notice you are given the height and the hypotenuse in your biggest triangle. Okay? Now we can compare the height to the height, x to 3, and the hypotenuse to the hypotenuse, 4 to 5. Now this is what I want you to see. When you finally cross multiply, you're given x times 5 and 3 times 4, which is 12. And I want you to notice this. You have the exact same problem in the previous proportion. We have 5x equals 12. In our new one, we have 5x equals 12. When you divide both sides by 5, you get x equals 2.4. And again, x is going to be the exact same answer. We already knew that. But just to show you that you could solve it using the smallest and the largest triangle, or you could solve it using the largest and the middle triangle. Either way, establishing the 3 triangles in the same position so that you can set up proportions and actually see, okay, I'm given the base and the hypotenuse. I'm going to use that and set it equal to the base and the hypotenuse. Or I'm given the height and the hypotenuse. I'm going to set that equal to the other height and hypotenuse. That is kind of going to be the hardest part. Most of you can solve proportions. You understand how to do that. But drawing these in a way that allows you to set them up so that you can solve the proportion, that's where a lot of kids are going to struggle. And it's not that you have a problem or that you're behind. This is just a tough section. This is a very difficult section for geometry kids. And so hopefully, we can spend a little bit more extra time solving it. Now what I'm going to do is I'm going to erase this, and we are now going to come over to this problem. We're going to label it letter B. Okay. Now what I want you to do right now, I want you to pause the video, and I want you to practice drawing the 3 triangles in the exact same position. And it's okay if you struggle, but I do want you to try it. Go through and redraw all 3 triangles in the exact same position, labeling all the angles and labeling the sides that they've given you in the actual diagram. Pause the video and try that now. Okay, hopefully you paused the video and were able to redraw the 3 different triangles that appear in this image. Now I'm going to highlight them before I show you the way I drew them and the way I labeled them. Now the largest triangle that we have is JLM. And you can see that that's the largest triangle. You can also see that we're given the length of the hypotenuse, we're given the length of the height, and given the length of its base. Now, the way that JML or JLM, however you label it, is drawn is very, very important. You can see that the hypotenuse is going up and left. We're given the base and the height, okay, drawn like this. The other 2 triangles that we have inside this triangle are JKM and MKL. Now what's very, very important is that you figure out what is the shortest angle or the smallest angle, where is the 90-degree angle, and so that you can draw all 3 of these in the same position. Now let me just show you the way that I drew them, and hopefully yours is very similar. You can see here that I have angle J. This triangle, my biggest triangle, is drawn exactly the way it appears in my drawing. The 90-degree angle is in the lower right corner. My hypotenuse is going up and left. And in clockwise format from the 90-degree angle, I have MJL. But then, in my medium triangle, or in this case my blue triangle, you can see that I put the 90-degree angle in the lowest right, the hypotenuse in the upper left. That allows me to maintain the exact same position as my biggest triangle, and then going from the 90-degree angle, clockwise format, I go KJM. And you'll see that I labeled the hypotenuse as 12 and the height as X, just like they gave me in the drawing. And then lastly, the smallest triangle, or in this case the red triangle, I again drew the 90-degree angle, or angle K, in the lower right corner, and the hypotenuse in the upper left. Now, if you don't understand how we got here, you want to make sure you stop, rewind the video, and watch it again. Because if you can't set these 3 triangles up first, then you're not going to be able to solve it. And I mean that in a nice way, because when we start setting up our proportions, it goes very, very fast. if you don't have these three triangles drawn in the same positions, and maybe you have them drawn upright, maybe you drew them like this, and that's fine too, as long as they are in the same positions. And the reason we want them in the same positions is this. If you look for your variable, here's my variable, you have to say to yourself, what other triangle am I given the exact same side? In this, x is my height. Well, where else am I given a height? Right here. I'm also in this problem because I need a proportion. A proportion is built with two ratios. So I have x to 5. There's one ratio. Remember, we use proportions to solve. A proportion is two ratios. Here's one ratio. I need another ratio. In this triangle, I'm also given the hypotenuse. Well, am I given the hypotenuse in this triangle? And the answer is yes. So I'm given 12 to 13. And now, once this proportion is built, everybody in the room can solve it. But setting up the proportion is what makes this section so difficult. Now, let's say that you are going to solve, let's use purple. Let's say you are going to solve for that variable. And it doesn't matter. Remember, just like the previous example, or the previous problem, letter A, we got the exact same answer for x. We got 2.4. We did it two different ways. We used two different proportions, and we still got the same answer. You can do that here. If you want to solve for this x, you have to ask yourself, x in this problem is the base. Am I given the base in any other problem? The answer is yes, right here. I'm also given in the same triangle the hypotenuse. Am I given the hypotenuse in this triangle? The answer is yes. And so you can use corresponding parts to set up your proportion. You can say x, whoops, not 5. I don't know why I said x and wrote 5. X to 12, because they're in the same position, they're both the base, should equal the hypotenuse to the hypotenuse, or 5 to 13. Now, maybe you need to rewind the video and redraw all three triangles. That's fine. Do that as many times as you need. You want to make sure that you have a firm understanding of how to redraw these triangles moving into the class period. Because if you can't redraw the triangles, then you can't solve the problems on the worksheet or the book assignment that we're going to do. So make sure that you practice this. This is very important. I have every confidence that everybody in the room, if they were given these proportions, could solve them correctly. Probably 80 to 90 times correctly. But if I asked you to give me the proportion and you had to do it yourself, that might be a little bit harder. That's where a lot of kids are going to struggle. And so, if you don't understand how we built these three, I would like you to pause the video, rewind it, and watch it over and over again. Okay? Now, we're not even going to solve these two. The reason we're not going to solve them is because you know how to solve a proportion. You cross multiply, you get 13x equals 5 times 12. Oh, look, we get 13x equals 5 times 12. You can solve that. I have every confidence you can. But some of you need to practice on just building them, just setting them up, just setting up the triangles in the same positions, which allow you to see, oh, I have the base and the hypotenuse, base and hypotenuse. That's where my proportion comes from. Maybe the next page, flip the page with me, maybe this page will help you. Because this deals with geometric mean. This deals with the altitude and the leg of our triangles. Now, in Theorem 7.6, or the geometric mean altitude theorem, it says in a right triangle, the altitude of the right triangle to the hypotenuse divides the hypotenuse into two segments. And what that means is, let me back up so you can actually see it. The hypotenuse, BD, pause, back up to where I said BD or hypotenuse BD. In the geometric mean altitude theorem, we're told that in a right triangle, the altitude cuts the hypotenuse into two symmetrical pieces. And now you can look at the proportion. We're told the altitude in this big right triangle is CD. And that it cuts the hypotenuse of my largest triangle is here, it cuts that into two smaller pieces, AD and BD. And this is what I want you to see. Maybe this is easier for some of you. If I redraw these two smaller triangles, I'm given ADB, or ADC, excuse me, and I'm given BDC. And in our largest triangle, what they tell us is that the altitude, CD, which occurs in both triangles, separates the hypotenuse of my longest triangle, my biggest one, into two smaller sections. And those two smaller sections are AD and BD. Now this is what I want you to see. By drawing the altitude in my largest triangle, what I did was identified corresponding parts in my two smaller triangles. You can use this idea of the altitude, breaking up the two triangles into corresponding parts. Notice we have the base, the height, the base, and the height. You can use that instead of redrawing all three. If that helps you. To me, visualizing all three redrawn helps the majority of the students. But if you understand this better, that the altitude breaks up the hypotenuse of your largest triangle into two separate parts, you can build a proportion that uses the base and the height of the medium triangle and the base and the height of the smallest triangle. Then let's look at geometric theorem, or geometric leg theorem. And in the geometric leg theorem, it tells me, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Still talking about AB and DB. Now what this is saying is that the legs, let me use a different color here, the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. And again, that is a whole lot of tough wordage for something that's similar, or that's something that's moderately simple. What I am going to do is I'm going to redraw these two smaller triangles just so you can see what we're talking about. I like redrawing them because that's what I can see. It's very visual for me. But let me go through and label these. We have the largest triangle. And actually, I'm going to redraw these so that they're in the same position as my largest triangle. My largest triangle has the 90-degree up and the hypotenuse down, so that's the way I'm going to draw them. I have D as my right triangle, or my right angle in this triangle. C would be here, and A would be here. And then in the other one, D is still the right angle, except that C is here and B is here. So, what this theorem, what the leg theorem tells us, is that the altitude, CD, which you'll notice occurs in both, divides the hypotenuse, which, let me get the same color going, the hypotenuse, which is the same as the altitude theorem, but here's the difference. When it divides it up into AD and BD, you'll notice that AD and BD are now the legs of my right triangle. Originally, what it showed me is the base and the height. Okay?